Okay, so this is 9.3b, and we're going to approach it very similarly as we did 9.3a. So the first thing we're going to do is we're going to take the Laplace transform of each term Okay, so here we know that the Laplace transform y prime is going to look like this. So we have s f of s, and then minus our function evaluated at 0, which we have here. So keep an eye out for that. Minus 1 equals the Laplace transform of t, which is 1 over s squared. So we get 2 over s squared, and then our Laplace transform of y is just another thing we should remember is our big F of s. So we have -3 big F of s. So condensing, we get s of s plus 3 F of s, and then equals 2 equals 2 over s squared plus 1. Okay, so I'm going to factor out an f of s. I'm left with s plus 3 equals 2s squared plus 1. Okay, so dividing through to solve for f of s, we get 2 divided by s squared s plus 3 plus 1 over s plus 3. Okay, and looking at this term, it's probably evident that we are going to need to apply a partial fraction decomposition. And like I said, I would fully expect you to have to do this on your test, so make sure you are comfortable decomposing stuff like this. So what we have is 2s squared s plus 3, and then equals a over s to account for the first term of the s squared, then plus b over s squared to account for the second term, and then plus c over s plus 3. Okay, now we can actually start solving for our coefficients. So the first thing we're going to do is we're going to multiply by this denominator. So we're going to get, we're going to get 2 equals a s times s plus 3. Okay, so all I did was I multiplied by this denominator, and one of the s's canceled, so we're left with this on our a terms. And then we have plus e, and our s squareds will make a factor of 1, so plus s plus 3, and then plus c, our s plus 3 will make a factor of 1, giving us s squared. Okay, so I'm going to keep the pattern of setting my s values equal to stuff so I can solve for as many terms as I can without having to do a lot of algebra. So obviously at s equals -3, these two terms will go to 0. So at s equals -3, we get 2 equals c times 9, or that c equals 2 over 9. Okay, so now let's set s equal to 0 because that will eliminate our a term and our c term. So we get 2 equals b times 3, or that b equals 2/3. Okay, and for our a term, I'm going to go ahead and make this smaller, so I don't think I can fit it. So for our a term, I'm just going to plug in the values we just solved for and then do some algebra to get our a value. So we have 2 equals a times s plus 3, and then plus 2/3 s plus 2, and then plus 2/9 s squared. Okay, so our 2's go away because we have some on both sides. And then this is going to look like 0 equals a s squared plus 3a s plus 2/3 s plus 2/9 s squared. Okay, so combining like terms, we get a plus 2/9 s squared. And from this term alone, we should be able to deduce that a is going to equal negative 2/9. But let's finish it out to make sure that there's no discrepancies later on. So we have s 3a plus 2/3. Okay, so looking at this, if a is equal to negative 2/9, this term goes to 0, and this term goes to 0 too. So that's this pretty good case that a equals negative 2/9. So now that we have all of our coefficients, we can actually take the inverse Laplace transform to solve for what we are trying to solve for. So we have f of s inverse Laplace transform that, and equals, don't forget about this 1 over s plus 3, because we didn't include it in our decomp, so we have to include it here. And then minus 2/9 times 1 over s, and then plus 2/3 1 over s squared, and then plus 2/9 1 over s plus 3. So hopefully you see that you can combine these so you don't have to do it twice. So you get the inverse Laplace transform of f of s equals, combining these gives us 11 over 9 times 1 s plus 3 minus 2/9 1 over s, and plus 2/3 1 over s. And one of these is an s squared, and it's our 2/3. I'm sorry about that. So our 2/3 here. Okay, so applying this inverse Laplace transform, I'm just going to, I guess I have to rewrite it since I didn't write it the first time. F of s equals inverse Laplace transform, all of this gobbledygook. In fact, I'm just gonna, y'all know what's up. We're just taking the inverse Laplace transform. So for this term, you have something that looks really similar to it in your table, but keep in mind in this instance, a equals -3. So you're going to have e to the at, where a is equal to -3. So that term is going to go to, so we have y of t equals 11 over 9, because we just carry our constant, and then e to the negative 3t. And that's because in this case, you have s minus a on your table. And so for that to be true, our a has to be a negative 3. And then the other ones aren't so complicated. You get plus 2/3, and then 1 over s squared just goes to t, and then minus 2/9. 1 over s is just 1. So we get a negative 2/9 there, and that is the whole problem. I hope that made sense. Please let me know if you have any questions whatsoever.